Hello friends, welcome to the second session of maths. Today we are going to look at fractions. You must already be having some idea about fractions. So can you recall, try to define a fraction? Mathematically, a fraction is defined as part of a whole. So when we are talking about things like half an hour or 1.5 times, no, we are not talking about numbers such as, we are not talking about whole numbers. We are not talking about numbers such as 0, 1, 2, 1, 2, 3, 4, 5, 6, that way. Right? We are talking about numbers that fall between two whole numbers. So those kind of numbers are fractions. They are usually defined as part of a whole. And how do we write them? We write them as numerator divided by denominator. So let's look at an example. Let's say we are talking about 5 pieces of pizza taken from 9 pieces. So we have one pizza like this, big pizza. This is how many pizzas we have? We have 1. So we are talking about whole number. But now we divide it into pieces. So let's say we divide it into 9 pieces like this. Okay, so like this we are dividing into 9 pieces and we are taking 5 pieces out of it. So we have the whole is 9 pieces, we are taking 5 pieces, right? So 5 is the numerator, this is called the numerator, this is called the denominator. This kind of a number is called a fraction. Some basic definitions for fractions. Proper fraction. A proper fraction is a fraction where the numerator is less than the denominator. So now you will see that this fraction that we just saw, 5 divided by 9. What is the numerator? 5. What is the denominator? 9. So this kind of a number is a proper fraction, right? And all proper fractions will be less than 1. So 5 by 9 will be less than 1, right? Because it's a proper fraction. We are dividing the whole pizza in 9 and we are taking only 5. So we still have some part of the pizza left. So it is less than 1. Improper fraction. A fraction where numerator is greater than denominator. Let's say for example 13 divided by 9. So we have one pizza that let's say we have one pizza, we split it into 9 pieces and we take 13 such pieces. Now the question is, if we have only 9 pieces, how can we take 13 pieces, right? So don't confuse yourself. What we are actually talking about is 13 pieces similar to pieces, individual pieces when we cut a pizza into 9 pieces. So we are talking about these 9 pieces and 4 pieces from another pizza where that pizza has also been split in 9, but we are taking 4 pieces out of it. So total we have 13 pieces and each pizza is split into 9. So you will see that we need more than one pizza for this, right? So that is why all improper fractions will be greater than 1. Some examples are 7 by 4, 9 by 2, right? And third type of fractions is a mixed number. So we are talking about whole number and a fraction. For example, let's say we are talking about 1 3 by 4, right? So here what we are talking about is one whole pizza and another set of pieces where a pizza is split into 4 and we are taking 3 such pieces. So we are talking about, let's say, one whole pizza and another pizza in which we have 4 pieces, but we are taking 3 of them. So this shaded region is what we are talking about when we talk about the number 1 3 by 4, right? And remember that when we talk about 1 3 by 4, or here in the example 6 2 by 3, 18 5 by 4. So when we talk about 6 2 by 3, we are actually talking about 6 plus 2 by 3. Don't make the mistake of thinking that it is 6 into 2 by 3. So because if it is 6 into 2 by 3, we can further simplify this, right? So we get 2 into 2 is equal to 4. 6 into 2 by 3 is something different. Whereas when you are talking about a mixed fraction, we are talking about 6 2 by 3 means 6 plus 2 by 3, right? So let's now have a look at how to convert improper fractions into mixed numbers. So we just saw in the earlier slide that improper fractions are fractions such as, let's say, 6 by 4, right? And they are greater than 1. So if they are greater than 1, we should be able to write them as some whole number plus some proper fraction, right? So let's look at how to do that, how to split this improper fraction, how to split 6 into 4 into a mixed number. So first thing we do is divide the numerator by the denominator. The resultant becomes the whole number and the remainder becomes the numerator of the new fraction. Okay, so let's look at how we can actually do this. So let's say one example we have is 47 by 5. Okay, so 47 by 5 is an improper fraction, right? Why? Because 47 numerator is greater than denominator. 47 by 5. Okay, so what does this say? The first step is divide the numerator by the denominator. So let's divide 47 by 5. So 47 divided by 5 is equal to, how many 5s we can fit into 47? We can fit 9 whole 5s, right? And remainder of 2. Remainder is equal to 2. Correct? Yeah. So now what we get is, we write 9, we write 2 here, and we write the same, we keep the same denominator. Correct? So this becomes our mixed number, which is the same as 47 by 5. Right? Now we just saw, right, that 9 2 by 5 is actually 9 plus 2 by 5. Correct? So now let's do this 9 plus 2 by 5 and let's see whether we get 47 by 5. So 9 plus 2 by 5, so we'll have to get the common denominator first. We get 5. Okay, so 9 into 5 is 45 plus 2, so we get 47 by 5. We are going to cover this operation. If you don't understand this operation, it's going to come in the next slide. So using that, you will be able to verify that 9 2 by 5 is indeed equal to 47 by 5, right? So if you don't understand this calculation, that is fine, it is going to come in one of the subsequent slides. So let's re-look at it. 47 by 47 over 5 equal to 9 with a remainder of 2. So 47 by 5 becomes 9 2 by 5. Let's also now look at converting mixed numbers into improper fractions. So we just saw how to convert improper fraction into mixed numbers, and now we'll see the other way around. We'll see mixed numbers into improper fractions. So what we do is multiply the whole number by the denominator and add it to the numerator. Right? We just saw this on the last slide. So we are talking about, let's say, 9 2 by 5. What do we do? Multiply the whole number, that is 9, by the denominator, which is this. So 9 into 5 is 45, and add it to the numerator plus the numerator, the whole divided by 5. The denominator will always remain the same. So we are talking about 47 by 5, right? How this works, we will see that in the next slides, where we will deal with operations of fractions. So convert 9 2 by 5 into mixed number. 9 into 5 is 45. 45 plus 2 is equal to 47. So we are talking about 47 by 5. Okay, so now let's look at the rules for operations on fractions. So the first type of operations we'll see are addition or subtraction of fractions. So the rule here is, when we are adding or subtracting fractions, the first thing you have to do is to get a common denominator. Without a common denominator, you cannot add or subtract any fractions. Then once you get the common denominator, what we do is add or subtract, depending on which operation we are performing, add or subtract the numerators while keeping the denominators the same. Okay, let's see how to use this rule in action. Let's say we are talking about adding two numbers, 1 by 10 and 5 by 40. Let's say 1 by 10 plus 5 by 40 is the operation we want to do. What is the first rule? The first rule says get a common denominator. So this is denominator, we have 10, here we have 40. Now we have to get a common denominator. Which one will be easier to work with? Which denominator we can think of? We can think of denominator as 40, because if we take 40, then we don't have to do anything to this fraction, and to this fraction we'll have to convert this 10 into 40, for which we will have to multiply this by 4. The same operation we'll also have to do on the numerator also, because otherwise the value will be changed. So basically what I'm talking about is this. I'm talking about 1 by 10 is equal to 4 into 40, sorry, this is 4 into 10 and 4 into 1. So we are talking about 4 by 40. By doing this operation, we are getting a common denominator of 40, right? So this fraction is basically 4 by 40 plus 5 by 40, right? So what we do is, we keep the denominator same, we just add the numerators, whatever the operation is, add or subtract. So 4 plus 9 is 5. So answer to this is 1 by 10 plus 5 by 40 is 9 by 40. Now it is possible that sometimes it has some common factors. Okay, like for example, if it was 12 by 40, then we can divide this by 4, both of them, and simplify it further. So what we can do is divide it by 4, so it becomes 3, numerator becomes 3, denominator becomes 10. We cannot simplify it any further. So this is in the purest form, this is the answer. But here anyway we don't have any common factors, so we'll let it stand as it is. Now it is not required that you choose the common denominator as 40. You can even choose it say, let's say 400. Let's say I want to convert everything to 400. So I do 400. What do I have to do here? If I want to convert this 10 into 400, I'll have to multiply this fraction by 40, or rather multiply numerator and denominator both by 40. So 40 into 1 will become 40. What do I have to do if I want to convert 40 into 400? I'll have to multiply this by 10. So I do the same operation on numerator also. So 5 into 10 is 50, right? So what we get is 40 plus 50 is 90 divided by 400. Now you will see that there is a common factor 10. So we divide this by 10. So ultimately what we get is 9 by 40, which is the same answer. So whichever common denominator you choose, you will get the same answer. Let's just quickly review this. What we are saying is, we are going to get a common denominator. Let's say we choose a common denominator of 40. So we convert the fraction that does not have that denominator by multiplying it by an appropriate number. That appropriate number here is 4. Now why this is 4? Because we will have to multiply 10 by 4 to get 40. So we multiply this by 4. We will also have to multiply the numerator by the same factor. So so 1 becomes 4. 1 into 4 equal to 4. So 4 by 40 plus 5 by 40. Then we do, oh sorry, this is a typo mistake. This is 9 by 40. This is 9 by 40 we are talking about. So let's now see how to perform multiplication of fractions. So when we have to multiply fractions, we have to multiply numerators together and we have to multiply denominators together. So for example, let's say we are multiplying by 6 by 7 into 5 by 9. We are performing this multiplication. So what does the rule say? The rule says multiply numerators together. So both these numerators will multiply together, both these denominators will multiply together. So numerator of the result will be the product of the numerators, which is 6 into 5 is 30. The denominator of the result will be the product of denominators, individual denominators. 7 into 9 is 63. Okay, now we can see that there are some common factors here. This is also divisible by 3, this is also divisible by 3. So we'll get rid of that. So we divide this by 3, it becomes 10. We divide the denominator by 3, so it becomes 21. So can we further simplify this? The factors of 10 are 2 and 5, whereas factors of 21 are 3 and 7. So there is no common factor. So this, in the purest form, this is the answer. So let's quickly review multiplication of fractions. Multiply numerators together, multiply denominators together. So 6 by 7 into 5 by 9 is 6 into 5 divided by 7 into 9. which is 30 by 63, which is 10 by 21. Let's also quickly look at the division of fractions. So as you know, division operation is basically the reverse of multiplication operation, right? So to divide a fraction by another fraction, what we do is we multiply by the reciprocal of that fraction. For example, we are performing, let's say, 6 divided by 7 divided by 5 divided by 9. So what we do is we take the same operation as 6 by 7, multiply by reciprocal of this. Reciprocal of this is we just change the numerator to denominator and denominator to numerator. We just do it, we just turn it upside down, right? And now we know how to perform the multiplications. How do we do the multiplications? We consider the numerators together, we consider the denominators together. So what do we get? 6 into 9, which is 54, divided by 7 into 5. What is 7 into 5? 35. Right? Do we have any common factors here? We don't seem to have any common factors here. So we'll let it stand like this. Just quick review. 6 by 7 into 9 by 5, 6 by 7 divided by 5 by 9 is 6 by 7 into 9 by 5. So we'll club this 6 and 9 together, all the numerators together, all the denominators together, and let the new numerator be product of individual numerators, new denominator product of individual denominators, and this is what we get. Okay, comparing fractions. While comparing two fractions, cross multiply. The number whose numerator produces greater product is greater. Okay, let's see it in action. Which fraction is greater, 4 by 15 or 1 by 5? Okay, so what we can do is, let's say 4 by 15 and 1 by 5, right? So what does the rule say? Cross multiply. What do you mean cross multiply? We look at this product, 4 into 5. We also look at this product, 15 into 1. So 4 into 5 is 20. 15 into 1 is 15. Correct? Now let's look, we'll compare these two numbers. Which one is higher? Obviously 20 is greater than 15, right? And 20 is the product of 4 and 5, right? Now which number, or rather which fraction of these two has the numerator, that means either 4 or 1, which of these fractions has a numerator that produces this 20? So obviously this 20 has come from 4 into 5. So we are talking about this fraction whose numerator has been used to get the greater number. So this fraction is higher. So we say 4 by 15 is greater than 1 by 5. So once again, what we do is we cross multiply. We write it next to the numerators. So 4 into 5 is 4 into 5 is 20, 15 into 1 is 15. Now 20 is higher, so we just do this sign, right? So you don't even have to think which numerator is gone. If you write the product next to the numerator, it will always help you, right? So let's quickly look at it. Cross multiply. Numerator 1 into denominator 1, numerator 1 into denominator 2. So we are talking about, this is the first fraction. Numerator 1 into denominator 2 is 20. Numerator 2 into denominator 1 is 15. So 20 is greater than 15. So we conclude that 4 by 15 is greater than 1 by 5. 4 by 15 greater than 1 by 5, right? Another way to do this is get a common denominator. That will always work. Let's say, what do we do to compare 4 by 15 and 1 by 5? So let's get a common denominator of 15 on both sides. So this remains like this, and what do you have to convert this to 15? We have to multiply it by 3. So we have to multiply the numerator also by 3. So we're talking about 3 by 15, right? So that means we have a pizza which has been split into 15 parts, and we have taken 4 parts in this number, we have taken 3 parts in this number. So obviously 4 by 15 is going to be 3 by 15, greater than 3 by 15. But no, but not all the time that you will be able to do this, because this involves getting it a common denominator, and numbers could be such that no, it is not possible, or rather it is not easy to get a common denominator. But this method, cross multiplication, will always work. So let's move to the practice problems. This is the first practice problem for you. You can pause the video and try to solve it. Okay. So which of the following fractions has the smallest value? So this question deals with fractions comparisons. So one way to deal with this is to take one fraction and try to compare it with other fractions and so on. But that will be a very long process. But there is a trick involved in this particular problem. So let's look at that. If you look at the first fraction, 1.1 divided by 3.3, you will see that it is somewhere close to 1 by 3. Right? This particular fraction, 15 divided by 45, this is exactly equal to 1 by 3. This particular fraction, okay, this is not so easy to figure out, but if you look at this, 446 into 3, we get 18, 1 carry, 13, 1 carry, and 13. So 3 times 446 is 1338, and this number 1347 is close to 1338. So this is also close to 1 by 3, and this 900, this is close to 900, so, and this is close to 2700. Not very close, but it is close. So this is also close to 1 by 3. So the trick here is that we just have to figure out which of them are greater than 1 by 3 and which of them are smaller. And then, because we are interested in finding out the smallest value, so then we'll look at the fraction that that has the smallest value. Okay, so let's see whether all these fractions are smaller than 1 by 3. The ones that are greater than 1 by 3 will eliminate right away. So this fraction, what can we say? What one change will make this fraction equal to 1 by 3? So if we have 1.1 divided by 3.3, this will make it equal to 1 by 3, right? Now look at this, 1.1 divided by 1 by 3 and 1.1 divided by 3 by 2. So which fraction is greater here? Always remember that when you have two denominators equal, like for example you have a divided by b and c divided by b, the one, because they have both denominators are same, the one with the higher numerator is going to be the bigger one. So if you say if a is greater than c, then a by b is going to be greater than c by b. But if you have the same numerator and different denominators, this is different. Okay, so you have the same numerator, different denominators, the one with higher denominator is going to be the smaller number. Why? Because we are dividing it into higher number of pieces. So a by b actually means a divided in b number of pieces, whereas a by c means a divided in c number of pieces. So the bigger the piece, bigger the denominator, smaller is going to be the number of pieces, right? So let's say we divide 10 into 2 pieces, we get each individual piece of 5. 10 divided into 5 pieces, each individual piece is of size 2, right? So the higher the denominator, the smaller is the individual piece. So if b is greater than c, then a by b is going to be smaller than a by c, right? So look at this, we have 1.1 common numerator and 3.3 and 3.2 here. So 3.3 is greater than 3.2, so that is why 1.1 divided by 3.3 is going to be smaller than 1.1 divided by 3.2, right? So that means what is this fraction? This fraction is 1 by 3. So 1 by 3 smaller than 1.1 divided by 3.2. So our number here in option A, our number here is greater than 1 by 3. So we eliminate this. So this is or rather we'll just make a note of it. We'll say that this is greater than 1 by 3. This number is easy to figure out. This is exactly equal to 1 by 3, right? Okay, now look at this number. Let's look at this. Let's see, we want to we want a denominator which will make 446 divided by that denominator equal to 1 by 3. So what would that be? That denominator will always be 446 into 3, right? So we just did this, 18 carry 1, 13, 13, 38. So 446 divided by 1338, which is equal to 1 by 3, and 446 divided by 1347. Now we have comparison between these two. So numerator common, the one with higher denominator will be the smaller fraction, right? So this is higher denominator, so this is going to be the smaller fraction, correct? So that means, what is this? 446 divided by 1338. So this is 1 by 3 greater than 446 divided by 1347. So that means this particular number, which is option C, is smaller than 1 by 3. So we say that this is smaller than 1 by 3. Correct? Look at this number. Okay, this number is also smaller than 1 by 3, because 907 divided by 2721 is going to be 1 by 3, right? How did I get that? I just multiplied this by 3. So 907 divided by 2721 is 1 by 3. So 907 and 2721 and 907 2607, if you look at it, this number is going to be smaller, correct? So that means this is 1 by 3 smaller than 907 divided by 2607, correct? So that means this number is also greater than 1 by 3. So which one would be the smallest number now? This number is greater than 1 by 3, this is equal to 1 by 3, this is less than 1 by 3, this is greater than 1 by 3. So obviously our answer is going to be C. This is the smallest fraction among all the given fractions. So the trick here was in observing that all these numbers are close to 1 by 3 and just figuring out how close to 1 by 3 or they are, and also eliminating all the options that are greater than 1 by 3. Let's move to the second question. What is the value of the following fraction? So you can pause the video and try to solve this. Okay, let's look at this. So we are given this particular thing which consists of 10 terms, 56, 57, 58 and so on till 65. So there are 10 terms, the whole divided by 55. Okay, now what we can do is, let's look at this. You observe that they are all sequential numbers, 10 sequential numbers after 55, right? And the denominator is also 55, so that should give you a hint. There is something related to 55 is being is required here. So what we do is we just split it. We split 56 as 55 plus 1. We split 57 as 55 plus 2. We split 58 as 55 plus 3, right? That way we continue till 65, which is 55 plus 10, correct? Divided by whole divided by 55. We club all these 55s together. 1, 2, how many of them? How many 55s we are going to have? We are going to have 10 55s, right? So we are going to have 10 times 55 together, plus 1 plus 2 plus 3 plus dash 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 till 10, the whole divided by 55, correct? Now the problem is very easy. We know this 55 and this 55 will ultimately get cancelled. We just have to look at evaluate the value of this. So what is going to be 1 plus 2 plus 3 plus 4 till 10? See, the formula here is 1 summation of 1 to n, is that is 1 2 3 4 5 6 7 8 till n is going to be n into n minus 1, n plus 1 divided by 2. This is a standard formula. Even if you don't know that, let's say at least for this particular example you will be able to calculate the value of this. The value is going to be, n is going to be 10, so 10 into 11 divided by 2, which is equal to 55. You always try remember this formula. Sum of all natural numbers from 1 to n is n into n plus 1 by 2. So this sum that we know it is 55, right? So this is 1055, 10 times 55 plus 55. So basically it is 11 times 55. 11 times 55 divided by 55. So 55 get cancelled. We are left with 11. So the value of this fraction is 11. Let's look at this problem. You can pause the video and try to solve it. So at a computer store, 1/5 of the computers are laptops, while 2/3 of the computers are desktops. What fraction of the computers are neither? Okay, so let's see. We have laptops, we have desktops, and we have other type of computers, right? And 1/5 are laptops, 2/3 are desktops, and let's say X is a fraction of computers that are other, right? So what can we say about this? We can say that 1/5 of the computers plus that are laptops plus 2/3 of the computers plus desktops plus all other fractions will make up 1. 1 means all the computers, right? So what do we get? We get X is equal to 1 minus 1 by 5 plus 2 by 3. So how do we find out this value? We get a common denominator. We get 15 as the common denominator. We get, why we get 15? Because 15 is 5 into 3. Here we are multiplying by 3. This fraction we are multiplying by 5. So we get 3 plus 2 into 5, which is 10. Correct? So what do we get? 3 plus 10 is 13. 13 by 15. So we have 1 minus 13 by 15, which is the same as 15 minus 13 by 15, which is 2 by 15. So 2 by 15 computers are neither desktop nor laptops. Let's look at this particular problem. Evaluate the following expression. So you can pause the video and give it a shot. Okay, let's look at this. So what we have here is 5 1 by 2 plus 5 1 by 3 plus 5 1 by 4 divided by 6 1 by 2, right? Okay, so we just saw in one of the earlier slides that 5 1 by 2 can also be written as 5 plus 1 by 2, right? Same thing with 5 plus 1 by 3 plus 5 plus 1 by 4 divided by 6 1 by 2 will be written as 6 plus 1 by 2. Correct? Okay, so let's look at this. We have 3 5s. 5 plus 5 plus 5 will give us 15, plus in bracket we have 3 fractions, 1 by 2 plus 1 by 3 plus 1 by 4 divided by 6 plus 1 by 2. 6 plus 1 by 2. Okay, now let's get a common denominator for everything. Let's get for these fractions, what would be a common denominator? 12 will be a good common denominator. So we'll write 15 plus 12. How do we convert 1 by 2 into something divided by 12? We have to multiply the denominator by 6. So we'll do the same thing in the numerator. So we'll multiply the numerator by 6. So it becomes 1 into 6 becomes 1. For this fraction, we're multiplying the denominator by 4. So we'll multiply the denominator by 4 again. 1 into 4, 4 plus 3. Why 3? Because these are the we are multiplying the denominator by 3, so we'll also multiply the numerator by 3. So this is what we get for this particular fraction, divided by 6 plus 1 by 2. How do we do it? 6 plus 1 by 2 can be written as 12 by 2 plus 1 by 2, right? Because 6 is 12 by 2. So this is what we get. Correct? Okay, now let's look at this. This what we get is 15 plus what we have here is 13. 6 plus 4 plus 3 is 13. 13 divided by 12 divided by 13 divided by 2. Correct? Now we have one more addition to do, this particular one. So for which we will try to get the denominator as 12 again. So what is 15? 15 can be written as, with a denominator of 12, what can 15 be written as? 15 can be written as 15 into 12 divided by 12. Right? So this, the numerator becomes 15 plus 13 by 12 becomes 15 into 12 plus 13 by 12 divided by 13 by 2. Correct? What is 18 into 15? 18 into 15, sorry, 15 into 12, it is 180. So this is 180 plus 13 divided by 12, and this is being divided by another fraction. So that means we can do the same thing by multiplying by the reciprocal of this fraction in the denominator. What is the reciprocal of this fraction? 13, 2 by 13. Correct? So let's simplify this further. We get 193. This 2 and this 14, this 2 and 12 have a common factor. So we will divide it by 2. So this becomes 1 by 6. So what we get is 193 divided by 6 into 13, which is 193 divided by 6 into 13 will be 78. So this is the answer to this particular expression. Let's move to problem number 5. Pause the video and see if you can solve this. Okay, let's read the question first. Lisa and Shannon brought an equal amount of money for shopping. Okay, let that be X. Let's say that Lisa and Shannon both got X dollars for shopping. Lisa spent $95. So now Lisa has, this is Lisa and this is Shannon. Both have X dollars to begin with. Lisa spent 95. So she spent 95. Shannon spent 350. What will Lisa be left with? She will be left with X minus 95. What will Shannon be left with? She will be left with X minus 350. Okay, so that much is given. After that, Shannon has 4 by 7 of what Lisa had left. Okay, after that Shannon had 4 by 7 of what Lisa had left. So that means Shannon had this quantity left, X minus 350. She was left with 4 by 7 of what Lisa was left with. So what was Lisa left with? She was left with X minus 95. So this is an equation that we get. How much money did Lisa have left after shopping? Okay, so we are asked to find out after shopping how much Lisa has. So we are asked to find out X minus 95. Okay, so from this equation we'll find out X, and then we'll find out X minus 95. So the equation solving very straightforward. We have seen it in the last class. Let's look at this. But this is a fraction here. So we'll have to get rid of the denominator first. So we'll have to multiply both the sides of the equation by 7. By doing so, we get rid of this 4 by 7. So we'll do the same thing. What we do is we get 7x minus 7 into 350, whatever that number is, right, is equal to 4x minus 4 times 95. Correct? So let's solve this. 7x minus 7 into 350 is going to be 0, is going to be 5, is going to be 24, right? 2450 equal to 4x minus, it's going to be 380. 4 into 95 is 380. Correct? So same, last time we saw we had to get all the variables on one side. So let's get 4x on this side and 2450 on this side. So we get 7x minus 4x, we get 3x is equal to 2450 minus 380, which is equal to 0720, right? So 2070. So that means x is 2070 divided by 3, which is equal to 690. So both of them had $690 to begin with, and the question is, how much money did Lisa have after shopping? So Lisa spent $95 in shopping, so she had X minus $95 left, which is 690 minus $95, which is $595 left after shopping. You can plug these numbers, you can plug the value of X and re-evaluate the whole scenario, and you will see that this the ratio of what both the girls had left after shopping will come out to be 4/7. So this concludes the second session of maths. I hope you enjoyed it, and I look forward to seeing you in the third session. Thank you.